So hello guys, today let's solve question number 172 factorial trailing zeros of Leetcode. So in this question they are giving us an integer n and we have to return the number of trailing zeros in the factorial of n. So yeah, it's pretty easy question, right? Find the factorial and find the number of trailing zeros in it. But so if you look at the constraints, the n is up to 10 to the power of 4, and if you don't know about factorial, the number of digits in factorial increase exponentially. So if you look at an example, so if you take an example of 30 factorial, it has a total of 33 digits. So this 30 factorial even exceeds the range of the long data type. So how do you even store when n is equal to 10 to the power of 4, which would be equal to 1000, as 1000 factorial is roughly 2568 digits. You can see how massive that number is. So normally there's another method to solve this question, like using manual multiplication and storing the result in a vector. But for this question, there's an even easier way to solve it. Let's see that. So consider 5 factorial, which is 120. We have a trailing zero of count 1. Why do we have the trailing zero? Because we understand that if you multiply any number with 10, we get a trailing zero at the end. And how are we getting 10 here? There's a 5 and there's a 2 which results to 10, and that's the reason we are getting one trailing zero. So with this knowledge, we can say that the number of trailing zeros appears would be equal to the number of factors of 5 and 2 of the given number. The bottleneck here is the 5. So just counting 5 factors of the given n number, we can get the number of trailing zeros. But if you just count the number of 5 factors and submit the question, you will get a wrong answer, because so consider 25 factorial. So now if you take 25 factorial and divide it by 5, you will get 5 as the answer. So let's actually check that. In 25, the number of times 5 appear is at 5. At 10, we have 5 into 2, so 1 5 appear here. Then at 15, at 20, and at 25. This is the reason you got 5 here as the number of factors of 5 and 25. But what if I say there are actually 6 5s? Because the 25 here, you can write it as 5 into 5, and you have to count 2 5s here, but just dividing by 5, you're only counting 1. So now what you have to do is, you also have to divide the n number by the power of 5 until you can no longer divide the number. 25 factorial will also divide it by 25, that then will get 1. Now if you sum the previous one and the current one, you'll get 5 plus 1, which is 6, and that will be the answer. And that's how you write the code for this. This is the code. We take the count and we take the divisor as 5. So we'll write count plus equal to n by divisors. We are dividing the n with the divisor 5 first. Then we'll multiply the divisor into 5 to get the next power of the divisor. And yeah, this is how you solve the question factorial trailing zero. See you tomorrow.